Okay, so this is actually the same problem that we did in class. However, there were a significant number of people missing, so I'm going to go ahead and step through this one again. So you have how to do it on file. This is from the Net Forces Scaffolded practice, and it's problem number 2. It says a 72-kilogram skydiver is falling from 10,000 feet. At an instant during the fall, the skydiver encounters an air resistance force of 540 newtons. Determine the acceleration of the skydiver at this instant. So let's take a minute and let's look through and identify some of the important information in this particular problem. First of all, there's a 72-kilogram skydiver. That's helpful. He's falling from 10,000 feet. Height isn't that big a deal where he's falling from, but the fact that he's falling, or she, is important. And at an instant during the fall, the skydiver encounters an air resistance force, that's helpful, of 540 newtons. So determine the acceleration of the skydiver at this instant. So we're going to go ahead and use the problem-solving process that we've been using. So that means we're going to start with a coordinate system. So up is positive, right is positive, left is negative, down is negative. And this would actually be one where you could flip your coordinate system if you wanted to. I'm going to go ahead and leave it the way it is for now. But like I said, you could flip it, and as long as you follow through with your signs, you'd be okay. I'm going to go ahead and draw a free body diagram now. So here's my skydiver. So take a minute and think about what the forces are that are acting on this skydiver. Well, in the problem it tells us that there's air resistance, right? So we know there's air resistance. And air resistance, the question is, why are we drawing it up? We know it's 540 newtons. We're drawing it up because air resistance, by definition, is a type of friction, and so it's going to resist the motion. So if the skydiver is falling, air resistance is going to be acting up. So the next question is, what other forces are there that are acting on this skydiver? Hopefully you're saying gravity, and that's right, because gravity is pulling the skydiver down. Now the question is, which is bigger, air resistance or gravity? Or are they the same? So take a minute. Here's something we should be remembering. The force of gravity is equal to weight, and that's equal to mass times acceleration due to gravity. Now, you can do some math in your head. A 72-kilogram skydiver, okay, that's a mass. Acceleration due to gravity is negative 9.8 meters per second squared. If we round it up to about 10, we can do that. 72 times 10 is 720. If air resistance is only 540 newtons, 720 is significantly bigger. So we're going to make sure that we show the force of gravity, never mind the crookedness of the arrow, is bigger than the force of air resistance. Now, let's talk about what are some of the things we know. We haven't been doing this, so this is something you're going to need to get used to, but the first thing I want you to do is write an F-net equation. And an F-net equation in this case is in the y direction. The only forces we have acting on the skydiver that we're taking into account really are up and down, or in the vertical direction. So that's why we have y right here. And we talk about the F-net because the F-net is another way of saying the sum of the forces. And knowing what the sum of the forces is important, because if the forces are balanced, then that means the object's not accelerating. It's going to keep doing whatever it's doing. Think about Newton's first law. An object in motion is going to stay in motion at a constant velocity, and an object at rest is going to stay at rest unless acted on by an unbalanced force. So we need to know what the net forces are that are acting in the y direction, because eventually we want to find acceleration. Well, we can't find acceleration if we don't know what the net force is. So, what are the forces that are acting in the y direction? Hopefully at this point you're saying it is the air resistance, which is right, and the gravity. So I'm going to take a minute over here. I erased that because we don't need it for now. So that means the net force in the y direction is the sum of air resistance and the sum of gravity. Now, let's write down other things we know. We know the force of the air resistance from the problem is 540 newtons. We know mass from the problem, up here, is 72 kilograms. We also know, even though it's not listed, that acceleration due to gravity is negative 9.8 meters per second squared. And we're using negative because we set down as negative, so that means gravity is acting in the negative direction as well. So now, if we go back up to this finding the F net, we know we could find the force of air resistance and the force of gravity. So here's what you want to think about. Our end goal is finding the net acceleration. Isn't that what it asks us for up here in the problem? Determine the acceleration of the skydiver at that instant. The problem is this. We can't find a net acceleration without knowing the net force. So we're going to go back up here to this particular problem, and we're going to say we need the F net in the y direction, right? So that's going to be the force of air resistance, which is 540 newtons, plus the force of gravity. Now, we don't know what the force of gravity is, but we know the equation is mass times acceleration due to gravity. So let's take a minute and do the math to figure that out. So 540 newtons plus 72 kilograms times negative 9.8 meters per second squared. That's going to give me 540 newtons plus, now 72 times negative 9.8 is negative 706. And remember, a newton is a kilogram times a meter per second squared, so that's good. We have our correct unit. And when I add these two together, I get negative 166 newtons. So what does that mean? That's probably the kicker here. Now we have this number, but the key is really, do you understand what it means? This is what we're saying. Because it's negative, the net force acting on the skydiver is negative 166 newtons. That means if you take the force of gravity here and take out the air resistance that's acting the opposite direction, the remaining force is the negative 166 newtons. So this is part of why we were doing vector addition and subtraction, or essentially just vector addition, because you need to know this. So now that we have the net force acting on the skydiver, the overall force, or the sum of the forces, is a negative 166 newtons. So that means negative 166 means 166 down. We also know F net equals ma. That's really helpful, or you could say, by the way, ma net, same idea. That's really, really helpful because I know mass and I know my net force. So now my goal is to find my net acceleration. I can do that by dividing my mass out on both sides. So A net is going to equal F net divided by mass. And let me bring that back over here. My net force is negative 166 newtons. My mass is 72 kilograms. So my acceleration should be whatever negative 166 divided by 72 is. And I get negative 2.3 meters per second squared for my acceleration, which is right. I should have 2 sig figs. So that's my answer. So what does that mean? Think about it like this. The skydiver's falling, right? As you fall, you know gravity is accelerating you downward, so you're speeding up. Now the interesting thing is it's a negative number. So we're falling down and our acceleration is negative. That means we're speeding up as we're falling. So that's telling us that in this particular case, oops, sorry, give me just a second here. That's telling us in this particular case, the skydiver is falling down, but he's speeding up as he's falling at this particular instant in time.